Okay, Bismillahirrahmanirrahim. Assalamualaikum and hello everyone. Okay, so today I will continue with chapter 4.1 circle. Okay, so remember that before this we have learned to find the standard and also the general equation of the circle, given that we have the information of the radius and also we have the center of the circle. Okay, but for today's lecture we're gonna do the other way around, which is we will be given the equation of the circle and we have to find the radius and center of the circle from the equation. Okay, so there are actually two methods of finding the center and radius, which is the first one you're going to compare. Okay, we're going to use comparison for the first one, and then for the second one we're going to use the completing the square or the CTS method. Okay, so I'll show you both examples on how to use the compare and also completing the square. But before that, notice that actually the completing the square method has a wrong formula, okay, because there should be no 2 at the front of the G and also no 2 at the front of the F. Okay, so please cancel the 2. Okay, so please cancel and edit your note. Cancel the 2 in front. Okay, so now let's go through the first example, example 7. Find the center and radius of the circle. Okay, so for this example we're going to use the comparison method. We're going to compare. Okay, so what do we compare with? We can compare with the equation, general equation of the circle, okay, which is we have x squared plus y squared plus 2gx plus 2fy plus c equal to 0. Okay, so right now we cannot compare yet. Why? Because notice that we have 2 at the front of this x squared and also y squared. So what do we do with this whole equation? We're going to divide with 2, okay, to eliminate the 2 at the front. Okay, so now our equation of circle will be x squared plus y squared minus 4x plus 3y plus 5/2 equal to 0. So this is your new equation of circle. Okay, so now we're going to compare because it already looks the same. Okay, so what do we compare? So notice that we have x over here, the variable x, so we're going to compare the coefficient. Okay, we're going to compare the coefficient, which is 2g with -4, and then for y, okay, we're going to compare the coefficient 2f with 3, and the last one we have c with this. Okay, so I write it down. So the first one we have 2g equal to -4, so your g is -2. Second one we have 2f equal to 3 and your f is 3/2, and last one you have c equal to 5/2. Okay, so now when you have g, f and c, you can find the center and radius of the circle. How? Remember that the center, if we have the general equation of the circle, it will be -g, -f. Okay, so since our negative g is -2, so it will become 2, and then for f it will become -3/2. Okay, that is your center of the circle. And for the radius, we have the formula, which is radius equal to square root of g square plus f square minus c. So your g is -2 square plus your f is 3/2 square minus 5/2. Okay, so using your calculator, you will get the value of 15/2. Okay, so that's how you get the center and also the radius of the circle using the comparison method. Alright, okay, now for example 8, we need to find the center and radius of the circle by using method of completing the square. Okay, so we cannot use the comparing method for this one because the question asks us to use the CTS, and then we need to sketch the graph. Okay, alright, so looking at the formula over here, notice that we have already have the general equation of the circle, so now we need to rearrange our equation. Okay, so we have x squared plus y squared minus 6x plus 4y plus 9 equal to 0. So from here, we notice that they bring constant to the other side, and then the x they combine together, and also they combine the y together. Okay, so we have x squared minus 6x plus y squared plus 4y and equal to -9. Okay, alright, so when we have already this form of equation, now we need to figure out our g and also our f. Okay, our g and also our f. So in this case, your g is -6, your g is -6, and for your f it is 4. F is 4. So now we can insert into the equation, which is the equation is this. This is the formula for CTS. It will become x plus g/2 squared minus g minus g over 2 square plus y plus f over 2 square minus f over 2 square equal to your c. Okay, we just need to insert our g and f into this equation. Okay, so now we can simplify. So this one become x minus negative 6 divided by 2 is 3, negative 3. And then this one is negative 6 divided by 2 is negative 3. Negative 3 squared is 9. Okay, and then y plus 4 divided by 2 is 2. And then 4 divided by 2 is 2. 2 squared is 4. Equal to negative 9. Okay, so we bring all the constant to the other side. So negative 9 plus 9 plus 4. So it will become x minus 3 square plus y plus 2 square equal to 4. Okay, so now we already complete our completing the square. So notice that this is actually the standard equation of the circle. Standard equation of the circle. Okay? So when we already have the standard equation, we can easily compare because we already know what is the h, k, and also r. Okay, so remember, the formula for standard equation is x minus h square plus y minus k square equal to r square. Okay, so we need to compare. So h is equal to 3. So we know h is equal to 3, and then plus 2 is negative 2. So your k is negative 2. Your k is negative 2. And then we have r square equal to 4. So your r is square root 4, r equal to 2. There will be no plus minus at the front because radius will always be positive. Okay, so automatically you know that your r is 2. So now we already have all the information needed to find the center and radius of the circle. So the center is h, okay? So it will become 3, negative 2. And the radius is 2. Okay, that's how you find the center and radius of the circle using the completing the square method. Okay, alright, so now that we need to sketch the graph. Okay, we need to sketch the graph. So I draw x and y axis first. Okay, so this is our graph. So we have center of the circle 3, negative 2. So this is our x, this is our y. So 3, negative 2 is somewhere over here. This is 3 for x, negative 2 here. So this is your center. Okay, and then the radius will be 2. So the radius is, we have a circle, so the radius here is 2. So this is 2. The length of this from 0 to negative 2 is 2. So we know that our circle gonna touch the x-axis. And then this is length 3. So 2 is until here only. So the circle will look something like this. It will touch the x-axis, but not the y-axis. Okay, so yes, something like this. Okay, so this is how you draw your circle. Okay, done for example 8. Now we are going to learn to find the points of intersection. Okay, so the point of intersection of either two circles or a circle and a line can be found by solving their equations simultaneously. Okay, persamaan serentak. Okay, so let's say when you have the simultaneous equation, it will be either in this form or in this form. Okay, so we have constant a, b, and c. Okay, so actually there is trick for the value a, b, and c. So the first one is using the discriminant, which is the formula is b square minus 4ac. Okay, you substitute the value of b, a, and c, and you get it is greater than 0. So what does it mean? It is actually meaning that you will have 2 points of intersection. Okay, you have 2 point intersection. For example, if it involves two circles, you're gonna have 2 intersection. So let's say one over here and one over here. And if a line and a circle, you're gonna have also 2 intersections. Either it is here and also here. Okay, so that's the first case. Okay, so for the second case, we have b square minus 4ac, or this discriminant will be less than 0, or you will get negative value. So what does it mean? It means that either you have 2 circles that have no intersection at all, or you have one circle and a line that is no intersect. Okay, there is no intersection if you get smaller than 0. And the last one is if you have b square minus 4ac equal to 0. So this means either you have 2 circles that intersect at one point, or you have a circle and a line that intersect at 1 point. Okay, so that's the meaning for greater than 0, smaller than 0, or equal to 0. You can directly know what's your answer gonna look like. Okay, so we go through example 9 to find the coordinates of the point of intersection of the circles. So we have two equations of circles. Okay, so we need to find the point intersection. So we just need to solve them simultaneously. So the first one, we have x squared plus y squared minus 4 equal to 0. So this is your first equation. And then we have x squared plus y squared minus 2x plus 4y plus 4 equal to 0. So this is your second equation. Okay, so now we can actually minus equation 1 with equation 2, minus 1 with 2, because we can cancel out this one. Okay, we can cancel out that one. So I will minus. So 1 minus 2. Okay, so we have x squared plus y squared minus 4. So we have 0 x 0 y and minus 4. And then for second equation, x squared plus y squared minus 2x plus 4y plus 4 equal to 0. So we can now minus. The expression is minus. So this one 0, this one also 0. So 0 minus minus 2x. We will get positive 2x. 0 minus 4y is negative 4y. Negative 4 minus 4 is negative 8 equal to 0. Okay, so I rearrange my equations. So 8 plus 4y. So x is 8 plus 4y divided by 2. So x is equal to 4 plus 2y. So we get our third equation. Okay, we get our third equation. Okay, so now we're going to insert our third equations into either 1 or 2. So it will be easier if you use number 1. So insert 3 into 1. Okay, so insert into 1. So we have x squared plus y squared minus 4 equal to 0. So x is now 4 plus 2, y squared plus y squared minus 4 equal to 0. So I expand. It will become 16 plus 16y plus 4y squared plus y squared minus 4 equal to 0. So simplify the equation. So 4y squared plus y squared is 5y squared plus 16y plus 12 equal to 0. Okay, so now we have quadratic equation. You can directly use your calculator. So you get two factors. The first one is 5y plus 6. Second one is y plus 2. So you get 2 value of y. The first one is y equal to negative 6 over 5. And the other one is y equal to negative 2. Okay, so we are not done yet. Why? Because we need intersection points, right? Intersection points. Okay, so points is coordinate. So when you already have your y, so you need to find your x. Okay, so your x you can just insert into these equations. Your equation number 3. So at the first one, when we have y equal to negative 6 over 5. So your x is 4 plus 2, negative 6 over 5. So we will get 8 over 5. So that's the first one. And then for the second coordinate, we have y equal to 2, negative 2. Negative 2, so x equal to 4 plus 2, negative 2. So it is equal to 0. So the final answer is we have two intersection points, which is the first one is 8 over 5, negative 6 over 5. And the other one is 0, negative 2. So that is your point of intersection. Okay, so you're done. Okay, so let's now do example 10. So the question says a circle which lies in the first quadrant. Okay, so we have quadrant 1, 2, 3, 4. So the first quadrant is over here. And the circle touch x-axis, y-axis, and the straight line. Okay, so your circle will be touching y-axis, x-axis. So it looks like this, something like this. And also it touches a straight line. Let's say the straight line is over here. So 3x minus 4y minus 20. So our circle has center. And then the next information is the point F lies on the straight line. Okay, so somewhere on the straight line, the blue one, we actually have point F. So let's say the point is over here, F12. Okay. Okay. So now we will answer the question. So the first part of the questions. Okay, the first part the question, they want us to find the equation of the circle. Okay, so for equation of circle, we're gonna need two information. The first one is the center, the coordinate of the center, and the second one will be the radius. Okay, so how do we find these two information? So look at your circle graph. Okay, actually from here we can know the center. Okay, so notice that we know that from center to the circle, it is length r, right? The length is r, which is the radius. So from here to the center is actually also r. Okay, the length is r. So your x-axis, on your x-axis, this is actually r. Okay, this is actually r. Okay, this is r. Same as your y-axis. So this one is your r, so same as your y-axis, this is actually r. Here is r. Okay, so from this, we know that your center is actually r. Okay? Alright, so now we know our center. So your center, sorry, a minute. Your center is r. Okay, now you have to find the radius. Okay, so how do we find the r or the radius? Okay, we can actually use the formula that we have learned from previous lecture, which is this one. Okay, the perpendicular distance to the straight line. Okay, so we have straight line over here, so we can actually find the r. Okay, the perpendicular distance. So we can find your r. Okay, so based on the formula, this is the formula. The distance or the r is equal to this. So I write the formula, the modulus of AH plus BK plus C divided by square root of A squared plus B squared. So where do we find the A and also A, B and also C? So from the equation of line plus BY plus C equal to 0. Oh, sorry. Okay, so we have our A. Our A in this question is 3. Our B is negative 4. Our C is negative 20. So how about our H and K? So this is our H and K. Okay, this is our H and K. So now we can substitute into the formula of R. So R is equal to modulus of 3 times R plus negative 4 times R plus negative 20 divided by square root of A squared plus B squared. Okay, so R is equal to negative R negative 20 over 5. Okay, so now this is absolute equation. So you have learned from previous semester. So you have to define this. You have to separate into two cases. So the first one is R equal to negative R minus 20 divided by 5. And another one, you need to put negative at the front. So negative R minus 20 equal to 5. So 5R equal to negative R minus 20. So 6R equal to negative 20. R equal to negative 20 over 6. And for another one, you have 5R equal to R plus 20. So 4R equal to 20, your R equal to 5. Okay, so since we know that our radius will always be positive, so we have to reject this one. Okay, so that's how we know this is your R. So you need to reject this one. Okay, this is accepted because it is greater than 0. So now you already know your radius. So when you already know your radius, you can directly know your center also. Okay, so your center is HK or RR. So your center is 5. Okay, so we're not done yet because we have to find the equation of circle. Okay, so for the equation of circle, you just need to insert into the formula. For the standard form, we have x minus plus y minus k square equal to r square. So x minus 5 square plus y minus 5 square equal to 5 square is 25. So this is your final answer. So this is the equation of your circle. Okay. Okay, for second part of the question. Okay, for the second part of the question, you have to find the shortest distance from point F to the circle. Okay, so the shortest distance is actually here. Okay, wait, I draw for you. So we have the circle. Copy the square. Okay, so just need to look at this. Okay. So already know your center. Your center is 5. Okay. So actually the shortest distance is here. This is your shortest distance to the circle. Okay, so how do we do that? So first we can find the distance from the center to point F. So let's say I label this as H. Okay, you can find the distance between the center and also F. So how do we find it? Using the formula for distance. Okay, by using formula for distance, so H is equal to the square root of formula of length is x1 minus x2. So let's this one minus this one square. So 5 minus 12 square, and we need to plus with y1 minus y2. So 5 minus 4 square. Okay, so using your calculator, so you will get cert 50, which is 5 cert 2. So this is the length of H. Okay, but this is not the shortest distance because the shortest distance is actually only this. Okay, so let's say I labeled that one as D. Okay, from the center, from the circle to the point F, D. Okay, so how do we find the D? Notice that we can already know this one. This is actually R. Okay, so you know that this is R. So this is your H you have found using the formula of length, and then you have the radius, and you need to find your D. Okay, the distance between the shortest distance from the point to the circle. So from the graph, from the diagram, we know that your D can actually just equal to H minus radius. Okay, H minus radius. So you get your D, which is the shortest distance. Okay, so substitute into the formula. The D is equal to H to R, so 5 cert 2 minus 5, so it is 2.07. Okay, 0.7 units. Okay, because it is about distance. Okay, done for me. Okay, settle. Okay, so now let's find the equations of the tangent and normal to a circle. Okay, so what is tangent? So tangent is a straight line. Okay, straight line that is perpendicular to the radius. Okay, at a point. So this is a point. And normal is a line that is perpendicular to the tangent. Okay, so now we want to find the normal and tangent equations. Okay, we want to find the equation of the normal and tangent line. Okay, so how do we find the equation? So let's say we want to find the equation of tangent at point x1, y1. So let's say I label it here. So this is the point. Okay, x1, y1. Okay, the point usually will be given. So the equation of the tangent to the circle at point x1, y1 is using this. Okay, this is actually a method to find the tangent easily. Okay, so for this equation of tangent, you're gonna need to substitute a few things, a few constants. Which is the first one is x1, y1, which is your coordinate of the point given, and then you also need to substitute value g, f, and also c. Okay. Alright, so now let's try the example. Find tangent and normal line of this circle at the point s negative 1, negative 5. Okay. So we have circle and we have point, so we know this is x1, y1. Okay, so for equation of tangent, we're going to use this formula. So we already have x1 and y1, so we need to find g, f, and c. Okay, so how do we find it? We just need to compare with the general equation. So x squared plus y squared plus 2 gx plus 2 fy plus c equal to 0. So the equation given is x squared plus y squared minus 6x minus 10y minus 82 equal to 0. Okay, so from this, we're going to need to compare. So our 2g is equal to negative 6, so g is equal to negative 3. Our 2f is equal to negative 10, so f is negative 5. And for c, it is equal to negative 82. Okay, so now we already have the three informations that we need. We also have the x1 and y1. So what do we do now? We're going to substitute into the formula. Okay, so equation of tangent. Okay, so now we substitute into the formula. So x multiply x1, which is negative 1, plus y multiply y1, negative 5, plus g, which is negative 3, multiply x, plus negative 1, negative 1. Okay. Let me put bracket over here. And then plus f, your f is negative 5, y plus y1, your y1 is negative 5, and then plus c, so minus 82 equal to 0. Okay, it's quite long. Okay, so now we simplify, so we have negative x, negative 5y. Okay, and then we have negative 3, negative 3x and plus 3, negative 3x plus 3, and then we have negative 5y plus 25, and minus 82 equal to 0. So I simplify our equation, so negative 4x minus 10y, and then we combine all the constant, we have negative 54 equal to 0. Okay, so I divide the whole equation with negative 1, become 4x minus 10, plus 10y plus 54 equal to 0. Done. Okay, so this is your equation of tangent. Okay, now for equation of normal line, okay, how do we find it? So first we need to find the gradient, okay, the gradient of the tangent line. Okay, so remember that we have equation of line which is y equal to mx plus c, which is the m is the gradient. Okay, the m is the gradient. Okay, so first we need to find the gradient of the tangent first, tangent line. So this is the equation of tangent, so we need to rearrange until we get in this form. Okay, so 4x plus 10y plus 54 equal to 0. So 10y equal to negative 4x minus 54. So y equal to negative 4 over 10. So I simplify, become negative 2 over 5x minus 54 over 10. So y equal to negative 2 over 5x. And this one we can simplify, become 27 over 5. Okay, so now we already have the standard form that we want. Okay, so what is the gradient? So the gradient of the tangent is equal to plus 1, negative 2 over 5. Okay, so why do we need to find the gradient of the tangent? Because from this we can find the gradient of the normal. Okay, so we have another formula. So mt, the gradient of tangent, multiplied with gradient of normal is actually equal to negative 1. Okay, this is also another formula that is important for you to remember. So your mt is negative 2 over 5. So your gradient of normal line is equal to 5 over 2. Okay, so now when we already have the gradient of the normal, what do? We're gonna again insert into our equations of line, which is the equation of line is mx plus c. So in this case, we use the gradient of normal because we want to find the equation of normal. Okay, so it'll become y equal to the normal gradient is 5 over 2 x plus c. Okay, so now we are not done yet. Why? Because we have c, the value of c. So how do we find the c? We can substitute the point, this point. Okay, because y, the point is on the normal line. The point given is on the normal line. So that's why we can substitute the point into our equations. So y is negative 5 over 2. Your x is negative 1 plus c. So that's how you get your constant. C is negative 5 over 2. Okay, so you're not done yet. So when you already get your c, you need to substitute back. So now you know that your equation of normal line is y equal to 5 over 2x minus 5 over 2. Okay, that's your final answer. Okay, so now we already have the equation of tangent and also equation of normal. Okay, done. Last part of the video, we're gonna find the length of tangent from point to a circle. Okay, so let's say we have this diagram over here. So we have a point somewhere on the graph. So we have a point, and then we have a circle. So we need to find the length of the tangent. Okay, the yellow one, we need to find the length of the tangent from a point. Okay, so how do we find this length? So let's say this is our radius. We know that this is our radius. Okay, and notice that this is actually a right angle triangle with 90 degree over here. So this is 90 degree here actually. Okay, 90 degree. And let's say I labeled the length that we want to find as d, and then this one is h. Okay, so how do we find the d? Okay, we can actually use the Pythagoras theorem. Okay, which is if you have this right angle triangle, okay, which is, this is A, B, and C. So we know that A square equal to B square plus C square. This is Pythagoras theorem. Okay, so now looking at our situations, so from this we can write the formula, which is H square will be equal to R square plus D square. Okay, looking at this, we will get this formula. Okay, so we want to find D, right? So D square is equal to H square minus R square. Okay, so since we want to find D, we need to square both sides, so the right hand side will be H square minus R square. Okay, this is how we get the formula. Okay, so again, why there is no plus minus at the front? Because this is distance, this is length, this is length. So the length or the radius or the distance will always be positive. Okay, that's why there will be no negative at the front. Okay, now let's do this example. Find the length of tangent from point K to the circle. Okay, so we have circle. Oops. We have a circle. Oh, it's not a circle. We have a circle, and we have a point over here. K, point K with coordinate 4, 6, and now you want to find the length, the length of tangent from point K to the circle. Okay, so we have center somewhere over there. This is your center. So you have radius, and also you have the hypotenuse. Okay, so the 90 degree will be here. Okay, so we have radius and we have H, and we will have to find the distance, which is, I label it as D. Okay. Okay, so we are given the equation of the circle. So from the equation of the circle, we can get the radius and also the center. Okay. So how do we get the center and also the radius? Using the comparison method. Minus C equal to 0. Okay, so this is from the equation, and we know that our general equation is x squared plus y squared plus 2gx plus 2fy plus c equal to 0. So from this, we know that our negative 4 is equal to 2g, so g is equal to negative 2. Our 2f is equal to, oh, 2fy, sorry, 2fy. Wait, I write it again, sorry. Plus y squared plus 2gx plus 2fy plus c equal to 0. Okay, now we compare our f, so our 2f equal to negative 2. So our f is negative 1, and your c is equal to negative 6. Okay, so from this information, we're going to get our center. So our center is negative g, negative f. So it will become 2, 1. And then our radius r can be found using the formula g squared plus f squared minus c, and if I get the square root, so negative 2 squared plus negative 1 squared minus 6. Okay, so using the calculator, you will get cert 11. Okay, so we know now our r is 11. Okay, so first we can find the h. Okay, because we already have the r, now we can find the h because we already have the coordinate of the center, which is 2, 1. 2, 1. So we can find h using formula length of distance. Okay, so we need to find h first using formula of distance. So h is equal to square root of, okay, again remember the formula for distance, x1 minus x2. So 2 minus 4 square plus y1 minus y2. 1 minus 6 square. Okay, that's the formula for distance between 2 points. Okay, so using the calculator, we'll get cert 29. Okay, so now you already have your h, you already have your r. So now we're going to use the Pythagoras to find our d. Okay, so now find d. So again, from the formula, we know that d is equal to square root of h square minus r square. So cert 29 square minus 11 square, and don't forget the square root. So the final answer would be cert 18, or 3 cert 2 units. Okay, so this is your length of tangent from point to the circle. Okay, so now we are done for chapter 4.1. Bye guys.